Imagine a massive dam holding back a calm reservoir beneath which hides one of the most ingenious machines humanity has ever built. The hydroelectric power plant, a silent giant that continuously transforms the power of water into electricity. It might seem like water simply flows down from the dam, but in reality, it triggers an entire symphony of physics and engineering. Water is one of the cleanest and most reliable energy sources ever harnessed, and everything begins with the simple force of gravity. When water is stored in a reservoir behind a dam, it accumulates potential energy, the energy of elevation. The higher the water level, the more potential energy it holds. This stored force is later unleashed as the water is released through intake pipes, flowing downward toward massive turbines. That's where the magic begins. The rushing water spins a large blade assembly called a Kaplan or Francis turbine. These work much like a water wheel, but with far more efficiency and under enormous pressure. The turbine is directly connected to a generator, a device that converts mechanical energy into electrical energy. Inside the generator are two main parts, the rotor and the stator. As the rotor spins, it creates a changing magnetic field that induces an electrical current. This current is then sent through a transformer and into the electrical grid. The entire process takes only seconds and runs non-stop, day and night, quietly powering homes, cities, and industries. To ensure everything runs smoothly, the entire operation must be precisely controlled. Modern hydroelectric facilities use complex control systems that constantly monitor flow rate, pressure, turbine speed, and output voltage. Operators in control centers oversee hundreds of parameters in real time and can respond instantly to any change, whether it's due to a shift in demand, a weather event, or a fault somewhere in the grid. Not all hydroelectric power plants are the same. There are three main types: run-of-river, storage, or reservoir, and pumped storage. Run-of-river plants rely on a steady natural flow and operate continuously without large reservoirs. Storage plants hold back large amounts of water and release it as needed, such as during peak electricity demand. Pumped storage plants act like massive batteries. They pump water uphill when demand is low and release it to generate electricity when demand spikes. Pumped storage plants play a critical role in today's power grids. They can ramp up from standby to full output in just a few minutes, helping stabilize sudden shifts in supply or demand. In combination with renewable energy sources like solar and wind, which depend on weather conditions, pumped storage provides much-needed backup. When the sun isn't shining or the wind isn't blowing, water can keep the lights on. Hydropower is incredibly efficient, converting up to 90% of the water's kinetic energy into electricity. In comparison, coal plants typically reach only 30–40% efficiency. Hydroelectricity also produces no greenhouse gas emissions during operation, and, when properly designed, can serve additional roles such as flood control, irrigation, and recreation. However, it's not without downsides. Large dams can displace communities, alter ecosystems, and flood vast areas of land. That's why modern designs include features like fish ladders and minimal river disruption to reduce environmental impact. Another remarkable feature of hydro plants is their longevity. While solar panels last around 30 years and wind turbines about 20, hydroelectric stations can operate for over a century. With regular maintenance, upgrades to bearings, and modern control systems, these plants continue delivering power generation after generation. Some of the oldest hydro plants still in operation today were built more than 100 years ago and are still running strong. Globally, hydroelectric power provides about 16% of the world's electricity and accounts for over 50% of all renewable generation. In countries with significant river systems and mountainous terrain, hydro remains the backbone of energy infrastructure. The largest facilities can generate thousands of megawatts, enough to supply power to entire regions. And in places where rapid demand shifts must be met instantly, hydro remains one of the fastest reacting and most reliable sources of energy. Hydropower is fascinating not just because of its scale, but because of its silence. No smokestacks, no fumes, no roaring engines, just water flowing and generating a force that quietly runs our modern world. It's a triumph of human engineering that uses nature not to conquer it, but to cooperate with it. So next time you walk near a dam, cross a river, or turn on a light at home, remember that somewhere out there, hidden beneath tons of concrete and steel, a system is at work. A system that transforms falling water into invisible currents, powering your phone, your fridge, and your future. You're watching Almost Fiction, a place where we break down how the world actually works. No exaggerations, no hype, just facts, context, and clarity. We've shown you how GPS works, why airplane windows are round, what happens when a bird hits a jet engine, and how your voice sounds so different to others. We've explained Bluetooth, explored why the ocean is blue, and even imagined what would happen if the moon disappeared. Today you dove deep into water, into energy, into one of the quietest revolutions in human history. You learned how a reservoir becomes electricity, how a turbine turns motion into light, and how engineers keep our lives running on nothing but the force of gravity and the flow of a river. That's what Almost Fiction is about, the hidden mechanisms that keep the world turning, often unnoticed but always essential. We don't just tell you how something works. We show you how it all fits together. Every cable, every machine, every system, it's all part of a story. A story of innovation, failure, discovery, and purpose. And that story is what we bring to life every single week. If you're fascinated by how things really work and you're tired of shallow answers, hit that subscribe button. Turn on notifications and be here next time when we explore how cell towers switch your call mid-conversation, how data crosses the ocean, or how cars can stop themselves without a driver. We'll break it down, clearly, deeply, and without the fluff. Almost Fiction. The facts you should have known all along.